Hello people, it's me, Hui. I'm showing information about the DEEFLEXX system and some tips and tricks on my channel. If you like the content, you should subscribe the channel and hit the notification bell. There are and there will be some more of these experiments. In the past I spent a long time to improve those beam blocking devices to solve the problem for guitarists when they claimed about this shrill beam or when they told me I can't hear myself. I tried gaffer tape, flat discs or dome-shaped bodies and other reflectors. My friends and later customers never were happy with those solutions, so I started to work on a different sound dispersion device. DEEFLEXX systems were born about 10 years ago, but that's another story. You can watch the full video afterwards. Today I want to talk about the differences of beam blocking devices and DEEFLEXX. I will use the term Beamblocker only as description of a group of beam blocking devices like beer mats, CDs or even ALP. I don't mean any specific devices with similar names. I used a single recorded loop and sometimes just a part of it to hear very quick repeated AP tests. I used an E chord and a distorted sound. So the frequency range starts at 80 Hz and the overtones caused by the distortion reach up to 10 kHz and more. There are essential differences in the physical functions and acoustic effects of the devices. In the first AP test I recorded 2 rhythm guitars and a lead guitar. Nothing was changed in the signal path except I replaced a DEEFLEXX with one of my Beamblocker models. Why is there so much difference? Why does the Beamblocker model not spread the sound the same way? Before I will start with other AP tests, we need to know about some physics. How are sound waves reflected and what is the impact of the wavelength? I will keep it as simple as possible. You should not skip this part because it will give you the arguments when you are talking about this often discussed topic. If a sound wave hits a reflector at an angle, it is deflected with the same angle. The higher frequencies we are talking about behave similar like a light beam in a mirror. Entry angle is exit angle. Now try to imagine a beach with one small wall in the water. Here come the waves, 1, 2, and they are moving towards the beach. As there is no rock or wall big enough, the waves reach the beach as there was no barrier. Now we insert a wall, but crossways into the water. The big part of the waves hits the beach like before. Here, along the length of the wall, the wave is reflected. I know this is not the correct way to explain a wavelength, but this picture in your head will help you to understand the next experiment. Sound waves are reflected when the length of the wave is shorter than the size of the reflector. For instance, a reflector with a diameter of 8 centimeters is 3 inch is able to reflect 4 kHz and higher. 30 centimeters is about 12 inch will reflect 1 kHz and higher. Listen to the samples and watch the frequency charts in the region of 1 kHz and 4 kHz. You see and hear the small reflector can only deflect 4 kHz and higher. The LP is able to deflect 1 kHz and higher. Another acoustic effect we have to talk about is the comb filter effect. If two identical signals reach your ears with a time gap in the millisecond range, phase cancellations will occur. To make you familiar with the typical sound, I recorded white noise and duplicated the track. Then I delayed the time of one track step by step from 0 to 84 samples, which is finally 1 millisecond. You hear this typical coloring of the signal as soon as a delay is involved. It sounds nasal with this significant reduction of the higher frequencies, like talking and holding your nose. When you put a reflector parallel in front of a speaker, the sound waves are reflected multiple times and reach the mic or your ear later than the direct signal of the cone. In the next A/B test I will show a standard miking with Beamblockers of different sizes and one DEEFLEXX. You can hear the Beamblocker reflector causes phase cancellations. The size has an influence on the high cut. The bigger, the more phase cancellations happen and the more the beam will be dampened on axis. As there are nearly 0 reflections back to the speaker, there are no comb filter effects audible with a DEEFLEXX system. To give you a better idea of phase cancellations, I move a calotte-shaped reflector in front of the speaker. You can hear the phasing depends on the distance of the reflector and the speaker. The coloring even increases when you are very close to the dust cap. Now I will show you the result when I move a DEEFLEXX in front of the speaker. You can hear there is no significant influence of the signal. You get the same result when miking a speaker with or without a DEEFLEXX. In the next test I set the mic one step in front of the cap at the heave of the ears. Again, I only used a part of the looped guitar phrase to make very quick A/B tests. It will be better audible when the mic is standing a bit closer to the cap. I added a sample of the direct mic cap so that you can hear that the deflected sound of the DEEFLEXX contains no phase cancellations. Of course, it sounds a bit fatter because the microphone had this proximity effect when it is close to the membrane. The A/B test with and without the Beamblocker model, however, shows this characteristic sound like the test with the white noise that you could hear before. Out of competition, I want to show you another Beamblocker. I could read over the years in forums that this is the perfect solution. You can hear there are the same phase cancellations like using one of those Beamblocker devices. On axis you can hear these very high frequencies that can pass through the hole because of their very short wavelength. Let's try to sum up the results of the acoustic tests, and I will tell you some more tricks of professional guitarists that they told me. To avoid hearing loss back in the days, guitarists used a thick dowel to cover the upper speakers of a 4x12 or when they tilted a combo amp. The more layers they used, the darker was the tone. With each layer, some strange low mids come up because the membrane cannot move freely anymore. Guitarists told me that they turned around their tilted cap back to the wall to hear themselves better. Again, there are phase cancellations involved. The phase chaos increases if it is an open back. The 180 degrees phase shifted waves of the back side are mixed with the front side sound. In the next step, Beamblockers came up and they were mounted in front of the speaker. Players told me that all these methods change their tone, and the main reason of this are these phase cancellations. The experienced guitarists increase the mids and maybe a bit of the highs to hear themselves better. The typical mid-range is about 1 to 2 kHz. A disc of 5 to 10 centimeters is 2 to 4 inch is only able to deflect much higher frequencies above 4 to 7 kHz. But the angle or curve of a beam blocking device is too flat to be able to deflect sound waves up or sidewards in the near field. You could hear this when the overhead mic was placed at the heave of a guitar player. No significant sound reflections upwards or to the side. A Beamblocker dampens the beam on axis and hardly deflects sound waves. You could hear this when the mic was placed to the side and above the cap. The sound waves are reflected multiple times between speaker and blocker, and therefore the comb filter effect cuts out several frequencies in the whole spectrum. As a result, you will hear a different sound character, like using different IRs of an IR loader. If you tilt the amp to point to your ears and you want to reduce these shrill frequencies, then a Beamblocker will reduce these high frequencies. The comb filter effect will delete several frequencies from the low to the high frequency range. The larger the diameter, the more frequencies are cancelled, the more the sound is changed, and the better shrill frequencies are dampened. A DEEFLEXX doesn't hardly reflect back to a speaker. You could hear that when the system was moved back and forth. It uses a bigger surface to be able to deflect those important mid and high frequencies above 1 kHz. When you move away from a DEEFLEXX cap on axis, the sound will not change from half a meter up to 7 or more meters. This is 20 to 300 inch. If you do the same with a Beamblocker, you still will have duller and brighter sounds. A DEEFLEXX system was invented to deflect the sound waves in all directions without noticeable phase cancellations or changes of the sound. Moreover, together with professional guitarists and studio techs, we created a sound design that smooths out the harshness and creates a bigger tone. You have to hear this in real. These effects cannot be compared with other deflectors or Beamblockers, even if they look like a DEEFLEXX. I guess you have found this video because you googled Beamblocker, DEEFLEXX or something similar to find a solution for your problem. I hope I could show you the fundamental differences so that you can find the right device to solve your problem. That's it. Bye bye. See you.